What if we could travel across galaxies faster than the speed of light? Is it science fiction or closer to reality than we think? The vastness of space, with its billions of galaxies and trillions of stars, has always captivated the human imagination. We yearn to explore the cosmos, to uncover its secrets and perhaps even find other forms of life. But the limitations of traditional rocket propulsion confine us to our cosmic neighborhood. Even reaching the nearest star system, Alpha Centauri, would take tens of thousands of years with current technology. The idea of faster-than-light travel, often relegated to the realm of science fiction, has intrigued physicists and science enthusiasts for decades. Could we circumvent the cosmic speed limit, the speed of light, and venture into the universe's unexplored depths? This is where the concept of warp drive emerges, a theoretical propulsion system that promises to revolutionize space travel as we know it. It offers a tantalizing glimpse into a future where interstellar voyages become not just possible but readily achievable within human lifespans. The speed of light, approximately 299,792 kilometers per second, stands as a fundamental constant in physics. Einstein's theory of special relativity postulates that nothing can travel faster than light in a vacuum. This speed limit has significant implications for space travel. It means that even at the speed of light, reaching our closest galactic neighbor, the Andromeda Galaxy, would take a staggering 2.5 million years. The vast distances between stars and galaxies have been the biggest obstacle to interstellar travel. Conventional rockets, while suitable for interplanetary missions within our solar system, are woefully inadequate for traversing the immense gulf of interstellar space. Chemical rockets, even the most powerful ones, are limited by the amount of fuel they can carry. The tyranny of the rocket equation dictates that to achieve higher speeds, we need exponentially more fuel, leading to impractically massive spacecraft. This limitation has fueled the search for alternative propulsion systems, pushing scientists to explore theoretical concepts that could shatter the barriers of conventional space travel. In 1994, Mexican physicist Miguel Alcubierre proposed a solution that sent ripples through the scientific community, a theoretical concept known as the Alcubierre drive, or warp drive. Unlike traditional propulsion methods that involve traveling through space-time, Alcubierre's idea proposed distorting space-time itself. Imagine a surfer riding a wave. The surfer doesn't move through the water so much as the water carries them along. Similarly, the Alcubierre drive envisions a spacecraft enclosed within a warp bubble. This warp bubble would compress space-time in front of the spacecraft while expanding it behind, creating a local distortion of the fabric of space and time. By riding this wave of distorted space-time, the spacecraft could effectively achieve faster-than-light travel without violating the laws of physics. This concept, though radical, offered a potential loophole around the speed limit imposed by special relativity. It ignited the imagination of scientists and science fiction writers alike, becoming a staple in many science fiction stories, including the iconic Star Trek series. To understand how the Alcubierre drive works, imagine a flat sheet representing space-time. Now picture a spacecraft placed on this sheet. Instead of moving the spacecraft across the sheet, the Alcubierre drive proposes manipulating the sheet itself. By compressing the space-time in front of the spacecraft and expanding it behind, the drive would create a region where the spacecraft is essentially stationary, while the distorted space-time around it carries it forward. This distortion of space-time can be visualized as a wave that the spacecraft rides. The spacecraft itself wouldn't actually move faster than light locally. It would remain within its local space-time bubble where the laws of physics remain intact. The key is that the warp bubble itself, propelled by the distortion of space-time, could travel at speeds exceeding the speed of light, carrying the spacecraft along with it. This concept, though still within the realm of theoretical physics, offers a tantalizing possibility for circumventing the limitations of traditional propulsion systems. Section 5. Expanding and contracting space, a visual journey. Imagine a rubber sheet with a ball placed in the center. This ball represents a spacecraft and the sheet represents space-time. Now, if you pinch the sheet in front of the ball and stretch it behind, the ball will move forward. This is a simplified analogy for how warp drive is envisioned to function. Instead of traveling through space-time, the Alcubierre drive manipulates space-time itself. It creates a warp bubble around the spacecraft that compresses space-time in front and expands it behind. This distortion effectively propels the spacecraft forward by riding the wave of compressed space. Imagine a surfer riding a wave. The surfer doesn't move through the water so much as the water carries them along. Similarly, the warp bubble carries the spacecraft along with it as it distorts space-time. Section 6, the energy challenge, fueling the warp drive. While the Alcubierre drive presents a compelling theoretical framework for faster-than-light travel, it comes with significant challenges, one of the most daunting being the energy requirements. Creating the space-time distortion necessary for a warp bubble requires an immense amount of energy, far exceeding anything currently achievable with our technology. Calculations suggest that the energy required to create a warp bubble is equivalent to the total mass energy of Jupiter, highlighting the immense scale of the challenge. Harnessing and manipulating such colossal amounts of energy is a hurdle that currently seems insurmountable. Traditional energy sources, even nuclear fission or fusion, are woefully inadequate for this task. To power a warp drive, we would need to discover and harness new forms of energy, perhaps tapping into the very fabric of space-time itself. Section 7, exotic matter, the key to faster-than-light travel. Another significant challenge lies in the need for exotic matter to create the warp bubble. Exotic matter, unlike the ordinary matter we interact with daily, has negative mass energy density. This peculiar property, though predicted by some theoretical models, has never been observed in the universe. Negative mass energy density is crucial for the Alcubierre drive because it's what would allow for the expansion of space-time behind the spacecraft. It's the stretching part of the rubber sheet analogy. Without exotic matter, creating the necessary space-time distortion for a warp bubble seems impossible based on our current understanding of physics. Finding, creating, or even proving the existence of exotic matter remains one of the biggest mysteries and challenges in the quest for warp drive technology. Section 8. Warp drives in the lab current research and progress. Despite the seemingly insurmountable challenges, the idea of warp drive continues to captivate the scientific community. Researchers around the world are exploring various aspects of warp drive theory, conducting theoretical calculations and even small-scale experiments to test some of the principles involved. While a functional warp drive is still firmly in the realm of science fiction, some progress has been made in understanding the underlying concepts. For instance, researchers are investigating the possibility of creating microscopic warp bubbles in the lab, albeit on a scale far too small to be practical for space travel. These experiments aim to test the basic principles of space-time manipulation and could provide valuable insights into the feasibility of warp drive technology. Section 9. A new era of exploration, the promise of warp drive. The development of a functional warp drive would revolutionize space exploration. It would allow us to travel to distant stars and galaxies within human lifespans, opening up a universe of possibilities for scientific discovery, exploration, and perhaps even the colonization of other planets. With warp drive, we could visit other star systems, study their planets and stars up close, and search for signs of extraterrestrial life. We could even venture beyond our own galaxy, the Milky Way, and explore the billions of other galaxies that populate the observable universe. The scientific discoveries that await us in the vast expanse of space are potentially limitless. Section 10. A future among the stars? The quest for warp drive is a testament to humanity's insatiable curiosity and our relentless pursuit of pushing the boundaries of knowledge and technological innovation. While it remains a significant scientific challenge, the potential impact of warp drive on our understanding of the universe and our place within it is undeniable. If we were to achieve this seemingly impossible technology, it would not just revolutionize space travel, but would fundamentally alter our perspective on the cosmos and our destiny as a species. It would usher in a new era of exploration, discovery, and perhaps even interstellar contact, forever changing our understanding of our place in the universe. The question remains, will we ever unlock the secrets of faster-than-light travel and take our place among the stars? Only time and continued scientific exploration will tell.